Okay, so knowing what we know about some different metals, let's take a look at an example. So here's a question here. What type of crystal direction corresponds to the movement of an interstitial carbon atom in alpha iron between some equivalent interstitial positions indicated by this coordinate, the half, 0, half. So we expect lots of interstitials that are represented by this point coordinates, which was a half, 0, a half. And so to help us, as we've seen alpha iron before, but we recall that alpha iron is an allotrope of iron, and it is the body-centered BCC crystal structure here. So when we think about this, let's just remind ourselves what that looks like. Okay, so body-centered cubic in the middle of this is an atom, and at the faces, therefore, we are we see eighths of atoms of iron which do not touch. And at each of the centers of the faces is an interstitial site. And that is what we were referring to here. Okay, so we've seen this before. At each of these interstitial sites, it's a potential spot for a carbon atom. And this is asking us to think about the movement of a carbon atom in one of these interstitial sites to another neighboring interstitial site, and to draw a vector and think about the Miller indices to show that vector, that movement of the carbon atom from interstitial site to other interstitial sites. Okay, so in order to show this, we might begin with our Cartesian coordinate system here. Okay, we'll put our unit cell on there. And now we want to perhaps just focus on where a carbon atom could be located initially. So we're given information that it might be at a half, 0, a half. So looking at that, we know we would go a half from the origin here, 0 in the y direction, and then up to the half position on the in the z direction. Okay, so this is on the face of that leftmost edge of this unit cell. And so that's identifying one spot for a carbon atom. And now we have to think about where the other neighboring sites might be. So remembering that all 6 faces of this unit cell are equivalent, we'd expect that there should be another vacancy at the center of the face up here, and another 4 around the outer edges of the remaining sides of this cube. So in other words, the possible direction for this carbon atom during diffusion of that carbon atom is along that direction. Okay, so we're starting at the leftmost edge in this case, and I've arbitrarily chosen that the carbon atom might migrate to the top edge of this unit cell. And we recognize that there are many different other interstitial sites that we could take advantage. So there's many directions here that are also equivalent to this direction. So the idea of families of directions is appropriate at this time, provided there's symmetry here, and we can identify that those other directions are the same. We can say that one particular answer may be just as good as another, because many vectors for this direction are going to be equivalent. Okay, so to provide a sort of set of descriptors for this vector, for this direction, we need to remember our rules for how to do this. So as we recall, we like to begin our vector at the origin. Okay, so I'm going to try to help do that by thinking about a neighboring unit cell, because this is only about halfway up this unit cell, and we need to project it to the next neighboring unit cell to help us. Okay, so we'll show that next unit cell over here. Something like that. And so the back projection of that arrow should go to about the center of that bottom face. And that would represent our a way to put an origin to help us with this. Okay, so now trying to put our new Cartesian coordinates there and try to sketch a unit cell where this now is at the origin of the green information. If my drawing was done well here, we should see that that is passing from there through along the diagonal and actually should intersect right here at the corner. Okay, so in other words, that would be the 0, 1, 1 direction. Okay, so this vector has a 0, 1, 1 direction there. Okay, if we follow our rules for this direction. Okay, so bit of a harder one considering we had to move our unit cell a half unit cell over to position the beginning of that arrowhead at our Cartesian coordinates, and then recognize that that arrow extended across the diagonal of one of the faces of this green unit cell and gave us the 0, 1, 1. Okay. Okay, so in other words, we sort of settled on this direction here in this diagram, a little cleaner than what I've drawn. We show that the center of the outer face, this is the rightmost face this time, was the beginning, and we move to an equivalent position on another face, and we would rotate and position the origin to consider that your Cartesian coordinate system to assign this vector. So as you might expect, because of all the symmetry of neighboring unit cells about this origin, we would get lots of options. And so this is one of those options. So this would be a correct answer for this question. Okay, so in the case of the next one, here it's asking us to think about gamma iron this time. So gamma iron, as we've seen before, is an FCC crystal structure. So a little bit different now, face-centered cubic. So we'll just remind ourselves what that is. So at the faces of each of these planes of the sphere are planes of the cube, are atoms. Okay, they connect across the diagonal there. Okay. And now we have to identify where the carbon atom would be, so it's an interstitial site. And so hopefully you can recognize this time that the interstitial sites are here, and here, and here, and here, etc. So they're at the midpoint of the vertices of all the planes of this cube. Okay. And so the same exercise, if we start to simplify our drawing, I'll try to draw that a bit better, focusing only on where the initial and final positions of one of these carbon atoms might be. We might be considering initially, for simplicity, this bottom midpoint on the where the leftmost edge meets the base edge, so the midpoint of that along the x direction here, for example. And we could consider moving that carbon atom to the next site. So say, for example, there. So in order to consider this direction now, recall that we are supposed to put that at the origin. And so back projecting this would mean it had started over here at the midpoint of the neighboring unit cell and had worked its way across that way. And so now putting our origin there for the next unit cell that is necessary to help us with the answer. Hopefully you can recognize here, perhaps a little easier in this diagram, that this direction is equivalent to the 1, 1, 0 direction. Okay, so that would be a way to provide an answer there. Okay, so there's another diagram showing those vertices, the midpoints of those vertices of each face of the cube and how the carbon atom might move from interstitial site to interstitial site that way. And here's a diagram showing you lots of different equivalent directions to suggest that there's many answers here. Okay,